All right, so good morning again, everyone. We are going to get started with the lecture for today. So we are still in our module dealing with the OOP concept, okay? And until now, we have been using the most basic features that Java has to offer in terms of object-oriented programming. Constructors, which is the main topic for today, the first topic for today, is going to be a feature that is starting to show all the technical aspects, everything that's going on behind the scene, when you create objects and stuff like that. So that's going to be very interesting from a technical point of view, and it's going to illustrate one of the difficulties of this course. Not saying that constructors are difficult to understand, but what I'm saying is that the difficulty of this course lies in understanding exactly how the object-oriented programming mechanics work, for example, in a language like Java. Okay, so this is exactly what we're going to deal with this. So that's going to give you a taste, of the kind of more complex mechanics that we're going to study between now and the end of the semester. So going back to the slideshow if I can. There we go. So we're going to talk about constructors. Well, as usual, we already talked about constructors, right? I like to repeat myself. No, it's not that I like to repeat myself, but I like to introduce things informally before we actually dig in and try to cover everything that there is to say about those things. So in the example of constructors, I already mentioned them. We saw them appear first in UML diagrams. And now we are going to actually try to learn everything we can about constructors. And we're going to be really, really close to cover 100% of everything there is to know just in this lecture. Okay, it's not that complicated. There's not that much there that can go wrong. But this is something that we're going to use 100% of the time until the end of the semester. So be careful. Make sure that you understand everything about constructors in this lecture, because then we're just going to keep adding on top of that. So here's a class, simple circle. So that's still the same class that we have been using as an example from the textbook, right? So inside of it, so now we can start naming things properly, right? So inside of it, there is an attribute. I could also call it a data field named radius of data type double. So this is exactly the same definition that we had before last lecture, okay? And then I have here my constructor. So one of the difference with the previous lecture was that the previous lecture I was just following the textbook example by the letter, right? And it had here double radius, and if I wanted a default value of 1, I would have put equal 1 before the semicolon right here, okay? Well, that's nice. That is nice, but like I told you last time, this is not exactly what I want to do in this course. Okay, so yes, it works. It can cause problem towards the end of the course, in the way that it interacts when we do inheritance, polymorphism, and stuff like that. So what I'm going to do instead is I'm going to say, okay, every time I declare an attribute, I'm going to declare it like that, double radius, like a variable, but I'm not going to initialize it just yet. And I'm going to leave all the work of initializing every single attribute in my object. I'm going to leave that work to a specialized method, which is the constructor of the class. So here comes my constructor. So simple circle, yeah, you notice that the constructor has the same name as the class, right? Takes no argument. And then the body of the constructor, the job that gets done every time I call it, is simply set radius to 1. If I had like, I don't know, 23 different attributes there in this class, my constructor job would be to make sure that the 23 different attributes are set to a proper default value. And how do you figure out a proper default value? It depends on your domain. Okay, it depends on your client, it depends on your requirement. Okay, so this is something that you don't have to make up. This is something that's going to be given to you, for example, in an exam. I'm going to say every time we create a simple circle object, I want the radius to be by default 1. Okay, unit circle. All right, so that's it. And at the very minimum, this is what a constructor will do. And in this class, like 80% of the time, the constructor is just going to initialize all the attributes. So it's not too complicated, right? It's not too hard to wrap your mind around. And then we have this get area method here. And I told you last time, so it's just a method from the class simple circle. When you're going to call it, you're going to call it on an object. of the class simple circle. So for example, my circle dot get area. And because it's not a static method, if it was a static method, I could call it on simple circle directly. Because it's not static, I have to call it on an object. And when you call this method on an object, it's like you are executing its code in the context of that object. What does that mean, the context of that object? That means that that object is going to have its own variable, its own attribute named radius. Okay, that's going to have its own value independently of the value of all the other attributes radius from all the other simple circle object. And when I run this code on my object, then when I refer to radius here, I'm going to refer to the attribute, and I'm going to more specifically refer to the attribute of that specific object. So here, called get area on a given object, I'm taking its radius times the constant pi, and there we go. You got your area for that particular simple circle. Okay, so again, radius doesn't have to be declared inside get area. Radius doesn't have to be declared inside simple circle. It's an attribute. Okay, so when you want to manipulate local variable are going to exist only during the execution of your method. Then think of them as temporary variable, right? I just need a variable the time for me to execute this method, and then I can trash it. An attribute is going to be inside every object. Every object is going to have its own version of the attribute, right? Its own copy, pretty much. And all the methods that you call on that object are going to access the same attribute. And when the method's complete, the attribute doesn't go away. Okay, it's permanently stored inside the object. So that means that I can create an object. The constructor will be called. I'll show you exactly how that happens. The radius for that object will be set to 1. Then if I call get area, I'm going to use 1 times pi. Okay. If I add another method, let's say set radius to change the radius, then I could call set radius on that object, say it's now 2, and the next time I call get area, it's going to be 2 times math.pi. Okay, so it's permanent storage for as long as your object is still around. And we're going to talk more about, when objects are like quietly disposed of by the JVM in a few slides. But as long as your object is still around in memory, all of the values inside all of its attributes are still stored. And every time you call a method, you access them. Okay, so in between call to method, the values are kept. So first thing about constructors. So first thing, I need to move this guy out of the way there. There we go, always getting in the way. So first remark about constructor is, so far I've showed you two different type of class, okay? Classes that had no constructor that was explicitly defined, so I didn't write a constructor, and we're going to talk a little bit more about that in a minute or two. And then I showed you class that had one constructor. Quick question in the chat. Could you ask and store a variable in an object using the input.nextIn command? Absolutely. Absolutely. So think of it this way. Attributes are variables. Until now, when I said variables, the only thing that I was talking about was local variable. A local variable in the main, a local variable in a specific method, right? And those local variable lived inside those method and existed only while you were running those method. Well, now we're talking about another level of variable, which is attribute, which exists inside the object and is stored permanently there. And when you call the method at the end of the execution of a method on that object, it doesn't go anywhere, right? This is what we just covered right now. But it's still a variable. So everything that you could do before with variables, assume that you can do it with attributes. The only difference is you have to tell me where to find the attribute. We're going to talk about the dot notation in a minute or two, okay? But you have to tell me that you want to access the attribute name radius inside that particular object. But once you have this notation, okay, then you can assign a new value to that variable. You can print it on the screen. You can assign to it, a value that you get by calling nextInt, like you suggested, okay? You can pass this value as a parameter. You can use this as a variable and do everything that you did with variables before, okay? that's how our concepts are going to scale a lot and fast in this class. Okay, is everything that we learn to do with basic stuff in Java, or that you learn to do with basic, variable in Python, etc. Once we define something else like an attribute, and we explain that it's pretty much like a variable that's located, in a different part of memory, then if you know how to find it, you know already all the stuff you can do with it. Okay, so very good question. All right, so I was saying that so far I've shown you only examples of classes that had a single constructor at most, no constructor at all returned in the class, or one of them, and sometimes it was empty like this one. So that was just a placeholder pretty much, and sometimes it did something very simple like the one that we just looked at in the previous slide. The first thing you have to know is that you can have multiple constructors in every class. So you're not limited to one constructor per class. For example, the first box here shows a snippet of code that would be inside a class named simple circle, and it shows one constructor that does nothing, okay? Just a placeholder. And then the second box here shows an example of the same class simple circle, but this time, instead of writing just an empty constructor, I wrote a very simple constructor here that just sets the radius to 1. And then I have a constructor that is a little bit more evolved, okay? That's going to take a parameter, take an argument, and that is going to say, okay, when you call the constructor, you are going to give me a new value for the radius, and I'm going to assign it to the attribute radius. So now I have two constructors, one that takes no parameter, one that takes no parameter. So is that okay? Well, if you try to write, twice the same method in Java, including constructor, it's going to be an error. So why is it that it's not an error here? Because even though the constructors have the same name, the methods have the same name, they take a different number and type of parameters. So that's their difference. Okay, remember we call that the signature of a method. The signature of the method is its name, how many parameters it takes, and the data type of each parameter. Well, we would say that the signature of this constructor method here is different from the signature of this constructor method. Question in the chat. Didn't grab your answer to Jake's question. My internet cut out for a second, so I can try to summarize that real quick, but you can check also the video afterward, okay? So summarizing real quick the question from Jake, the answer, like the too long didn't read answer, is you can do with attributes everything that you can do with variable. You can assign to them the result of calling next.int. You can pass them to other method. You can call a method, it returns a value, you put it inside that variable. Everything that we did with variable, we can do with attribute. The only difference is that a variable was always easy to name. Just put the name of the variable, and if you are in scope, you're good to go. But now for the attribute, we need to say inside of which object delete. So we need to use a reference variable generally to say, inside the object referred to by, for example, my third circle, I want to access the attribute radius, okay? And there is another way to access attribute radius. I'm going to mix in the answer to Jake's question with what we covered since then, okay? There's another way here that is illustrated, to access an attribute, which is just to say the name of the attribute. So hold on, you just told us that we had to specify which object the attribute was in. So why is it that I can just write radius here? It's because in every method of the class, including the constructor, if you write the name of an attribute of that class, it's going to assume that you're trying to access the attribute of whichever object the method is currently running on. All right? All right, cool, good. So we have like a kind of like the same thing, but it's slightly different. We still have the same, variables and do everything, but we are in a slightly different context. Question in the chat. So it's like des.attribute. So we're going to talk about the keyword des, yeah, but the keyword des can be used also to refer an attribute. You can use des.the name of an attribute. You can use just the name of the attribute like we just saw. And you can use also the name of a reference variable dot and the name of the attribute. Okay, so we are going to like summarize everything there is to know about the dot notation very soon, but you guys already got pretty much the gist of it. Yeah. That's pretty much 90% of what there is to know about the dot notation. That's how you access things inside of objects or inside of classes. So Attributes are like local variables. I would say, so it depends on what you mean by like, Gilberto, okay? They are like the local variable in the sense that they are variable. You can store a value inside of them. You can change their value later on. You can pass them as argument. You can use them in expressions, and so on and so forth, okay? So they are variables. But other than that, local variable and attribute are stored differently in memory. They're stored in different part of memory, and their life cycle is different. Okay, remember that a local variable, it comes into existence in memory when you enter the method where it's defined, and then it ceases to exist in memory when you leave the method where it's defined. Okay, so it's only during the execution of the method that it's there. An attribute is going to be there elsewhere in memory, and we're going to see exactly where. It's going to be there for the entire time your object is being used. Okay, so you call a method on the object, you return from that method. Doesn't matter, the attribute was there before you call the method, it's there way after you call the method. Okay, so it's independent of the life cycle of your methods pretty much. So there are still differences, okay? They are not completely like one another, but yes, they are still variables. So I wanted to emphasize, that everything you can do with variables, local variables, you can do with attribute as well. But there's more because of that storage difference. Attribute do something more than just local variable can do. So let's talk about some rules. These are going to allow you to spot easily, the definition of a constructor in a class. So the first thing that we notice is that constructors, and it's not on this list, but it should be, constructors are methods. So again, it's like the question that you just had about are attribute local variable. So now the question is, are constructors, just methods? Yes, they are methods, but they are special methods. They have some additional properties. Okay, so let's first talk about the fact that they are just methods. So most of the syntax that you know already on how to write a method in a class, you can apply to a constructor. But then there are specific rules, okay? The first rule is the name of the method has to be special. For a method to be recognized as a constructor for the class, for example, simple circle, the name of the method has to be exactly the same as the name of the class, okay? And I mentioned last time that, in Java, the convention is a name of a class starts with an uppercase letter, and then we do camel case notation, uppercase letter at the beginning of every word. And then the name of a local variable or the name of a method, you've seen me always, use names that start with a lowercase. Well, here's an exception. The methods that are meant to act as constructor will start with an uppercase because they mimic exactly the name of the class. Okay. Another thing that's weird, some of you might have noticed that, is that I always have, before the name of my method, I always have a data type. And that tells me the data type of the value that this method is going to return. And if I don't want my method to return anything, I've used that special keyword void. That means pretty much return nothing. Okay. When you write a constructor, you don't have that. You might have noticed, like if I go back, simple circle here doesn't have a data type, not even void, in front of it. So a constructor doesn't return anything, but you don't even notify the Java of that fact by putting the keyword void. The convention is, if the method you're writing is meant to be a constructor, don't tell me anything about what it should return, not including the fact that it shouldn't return void. Okay? So this is just syntax. This is just like special rules on how to write, a special kind of method so that Java can easily spot that method in your code and say, yeah, this is definitely a constructor. If you violate any of those rules, it's not like your compiler is going to necessarily crash or, issue warnings or error, but Java is going to look at your method and say, oh, you have something called simple circle, so the name match. But you told me that it returns void, so I must be mistaken. I thought this was a constructor, but clearly this is not. So I'm just going to consider it a regular method. And then problems happen, okay? But it's one of the silent errors most of the time. All right. Other difference between method and constructors. Well, methods, we call them, right? That's the whole point of writing a method, is that you want to be able to call it over and over and over again, reuse that code. Well, constructors are called as well, but Java takes care of calling them by itself. we don't have to call the constructor ourselves explicitly. In fact, we kind of do every time we write the keyword new. Every time we write the keyword new because we are trying to create a new object, okay, we put new followed by the name of the class, parentheses, and then potentially some argument. Well, that name of the class followed by parentheses looks awfully like us calling the constructor. Yes, it does. But as a matter of fact, it's not that we are calling the constructor so much as we are asking Java to call the constructor when it's appropriate after it's done creating the object in memory. And we are going to see that there are like 4 steps involved pretty much in creating an object the way that we have been doing it, for example, with scanners. And one of those steps is Java will apply to the object the constructor. And what if you have multiple constructors? Well, this is where it gets funny. This is where it gets interesting because if you have multiple constructor in the class, that means that you offer multiple ways to actually initialize the object once it has been created in memory. And guess who got to actually try to establish which constructor should be called? Java. Java is going to do it for you. But it's going to follow rules. We're going to study those rules so that you can write your code in your classes in a way that you can always predict which constructor is going to be called by Java when you create an object in a certain way. Okay? I know it's still a little vague the way that I describe it, but don't worry. Progressively, we are piling up concepts, and then we are going to look through code to really illustrate pragmatically those concepts. And then the last point, it's not really a rule here. I've been debating removing it from that slide, but it's just something that I want to remind you at this point. The role of constructors, like I just kind of said, is to initialize objects, right? So that means that when you create with a new keyword an object in memory, when Java creates a new keyword for you, when Java creates a new keyword, no, that's not what I meant to say. When Java creates a new object because you use a new keyword in memory, then after that, the constructor is there to set all the attributes to their default value. And sometimes you have a little bit more work to do, okay? It's not the only thing constructors do. Sometimes constructors are going to do much more work, but the philosophy of a constructor is, okay, the JVM created the object in memory, let's get it ready to use. So after the constructor is applied to an object, then that object should be 100% functional, 100% ready to use. You can call any of the methods on it in any of the order, normally, and you're going to get whatever results, the method is supposed to produce. So that's kind of your finalization of the object, the final touch on the object to make it usable. All right. Moving on. So we talked about classes that have one constructor, and I showed you an example where the constructor didn't do much. It was just a placeholder. I showed you an example of a class that had 2 constructors, okay, and we saw that they differed by the number and type of the argument. And we saw classes that had no constructors at all. So these are the classes that we use in COP2513. We never bothered. I'm trying to remember if there was an exception one day for whatever reason, but I cannot find one. We never bothered actually with writing constructors in COP2512, okay? Because we were just using the minimum features, that class could provide us. They were just a repository of static method. So in that context, we didn't need a constructor because we were never going to construct an object of that class, okay? So what happens when you don't have any constructor in a class? And because before I dig into that, let me address Jack's question. Is there a max amount of constructors a class can have, or can you have as many as you want? Good question. Now you made me curious because I never tried to stretch it. I do not think there is a limitation. I don't think there's any reason for which there would be a limitation in the number of constructors. They just all have to be featuring a different signature. Okay, so they all have the same name, granted, but they all have to have a list of parameters that's going to be different from all the other constructors. As long as you follow that rules, I am not aware of any limitation in the number of constructors that you may have. Okay, so the only pragmatic limitation would be maybe your colleagues tapping your shoulder and telling you, hey, what are you doing? 50 constructors, really? Do you think we need that much? And that's about it, okay? It's more like the human limitation than the compiler limitation at this point. So So what about this class that have no constructors? So we are going to first clarify something. A class in Java always has at least one constructor, sorry. It cannot have zero constructors. But I just said, that we wrote classes and we didn't bother writing constructor. So how do we reconcile the two statements, right? I can write a class with zero constructor, but you tell me that a class never has zero constructor in Java. It's because if you write a class and that class has zero constructors in it, no constructor at all, then Java is going to be kind enough to write a constructor for us and inject it in the class. So it's not going to inject it in the class in the sense of, you are going to see some code appear in your class. No, the code is still going to be your code. It's not going to be post-edited by Java. It's not going to suddenly have a constructor appear. So your code shows no constructor for the class, but when the class is compiled from a .java file to a .class file, the compiler is going to recognize that you have no constructor for the class, and it's going to insert in the .class file what we call a default constructor. Okay, and this is when knowing exactly what happens behind the scene has a direct impact on understanding what your code does, because now we're talking about Java adding during compilation time some code to the code that you wrote. And if you don't know that Java does this, then when you get some weird bug that involves that code that was added, you're going to stare at the screen, you're going to say the compiler went completely nuts. I didn't write any constructor, and yet it tells me that there is a problem with my constructor. What do you mean? So this is why we need to be aware of, to a certain extent, of what's happening under the hood. Okay? What is this constructor going to look like, this default constructor? Well, it's not going to take any argument, because Java is not smart enough to guess, what kind of argument you would want to pass to your constructor. So it's not going to take any argument, and it's not going to do anything in its body, because Java is not smart enough to guess, what are the default values that you potentially want to reassign to the attributes. So we are in a situation here where Java tries to add a constructor to our class. It does, actually, successfully so. But that constructor, he's doing nothing and he's taking no arguments. So why do we need it? We need it as a placeholder. Okay. Every class, because of the way Java constructs object, Java is always expecting to find a constructor. Okay, it has to find a constructor for the way that we construct object to work. And if you don't write a constructor, Java assumes that what you need is just a placeholder, something that Java can call and that's going to do nothing, but that has at least the merit of existing, of being there. Okay, and that's it. Java fulfills one of its own constraints, so that it doesn't have to bother the programmer with writing empty constructors like we have done. Like if I go back 2 slides, like I said, this kind of stuff, generally you wouldn't see it in code, like a single constructor in a class that takes no argument, does nothing. This is actually exactly what the default constructor looks like. So this can be automatically inserted by Java. We don't have to bother writing this kind of stuff. All right. What else? So I already mentioned that, but I want to re-emphasize it because this is a source of bug. Your default constructor is actually inserted by Java at compilation time only if you have absolutely no constructors in your class. Okay? If you have a constructor in your class, for example, let's go back 2 slides. There we go. If I have, let's say, this constructor here, simple circle, double new radius, okay? Forget about everything else. I have only this one constructor in my class. That's it. That's the only constructor my class will have. Java will not add a default constructor, if it finds at least a constructor. The logic behind it, to make it easy to remember, is if you provide at least one constructor to your class, you take control. As a programmer, you tell Java, listen, I know you need a constructor, I'm going to give you one, and that's the only one you need. If you provide no constructor at all, then Java says, I need at least one, and insert a default one. But Java is not going to pile up a default constructor on top of other constructor that you might have written already for your class. Very important. I'm pretty sure a proportion of all the student semester are going to encounter that bug at least once. You're going to make that mistake at least once. I just want you to be forewarned so that when you make that mistake, then you are going to remember the guy that was going on and on and on about that topic, and then this is where it's going to sink in. Okay. All right, so let's use constructor. I said we don't call constructor explicitly, but Java calls them for us anytime we create a new object. So the constructors are going to be called when we create new object. This is almost like the last step of creating an object. We finalize all the attributes, we polish it, and then it's ready to use. Okay, so you know the syntax to create an object. We have been using the single step syntax where we do everything on a line. You could break it down. You could say, for example, simple circle, my circle, semicolon, and then later on say my circle equal new simple circle, parentheses, semicolon. So that would mean first I declare a reference variable that is meant to hold a reference to an object of class my simple circle. And then later on, finally, when I'm ready, I create the new simple circle object and I put the reference to it inside my variable. I can do that, or I can do it just in one shot where I declare the reference variable and in the same swift motion, I assign to it the result of the reference to a newly created simple circle object. Well, let's wrap it up with this line of code because we've been using this line of code literally since, like the second lecture in COP2513 or something like that, when we created our scanner, right? Scanner s equal new scanner system.in and then semicolon. Yeah, well, now we have like all the pieces to explain completely what's happening. So let's go for it. Let's explain in detail exactly what's happening. When I execute this statement, and let me once again move this guy out of the way. There we go. So when you execute this statement here, the first thing that happens is we declare the reference variable named myCircle. So in memory, a local variable named myCircle, this is a local variable, I'm assuming, a local variable myCircle pops in memory. There's enough room inside of it to store a reference. A reference to what? To an object of type simple circle. That's the first step. Second step, if I can go to the second step, that is, thank you, PowerPoint. There we go. So second step, and this guy is still in the way. So sorry, I'm going to play hide and seek here with the webcam. So the second step is the new keyword is triggered. New keyword mean somewhere else in memory. So this is where your reference variable was allocated. Okay, somewhere else in memory, an object is created. An object of class simple circle. So I use a template of the class simple circle. Inside of that object, there is an attribute, only one attribute because that's what's the class feature called radius. And then there are a bunch of methods, but let's assume that we focus only on the get area method. So this is my object created in memory by the keyword new. Now that the object exists in memory, new is going to call the constructor that takes no argument. This is what I wrote here. I wrote, I want a new simple circle, and because I put the parentheses with no argument, I'm saying, once you are done creating the simple circle object, call on it the constructor that takes no argument. And that constructor, as you remember from the previous slide, that constructor is going to actually, sorry about that, is going to actually put some value inside all the attributes. So here it's easy, I have only one attribute, radius. Radius is assigned a 1, and that's it. Okay, my constructor did its job. So now the object has been created. It has been applied a constructor, one or more constructor. We're going to see that sometimes you apply several constructors to an object. But here, it has been applied one constructor that finalized it, made sure, to assign all the default value to all the attributes. And then the last step of this one-liner is once the object has been created and the constructor has been applied, then all I have left to do is assign the reference to that object, okay, to the variable myCircle. And now myCircle reference is a new object, and I'm ready. I'm ready to use the object, through the variable myCircle. MyCircle is really my way to access the object, my way to say, I want to do something with that particular simple circle object. Okay. So after I'm done executing those 4 steps, there we go. I'm fully functional. I'm ready to say, I want to do system.out.println, for example, myCircle.radius. Okay. Or I want to call myCircle.getArea. So that's going to lead us to the next slide, which is what do we do when we have those objects that are created? Well, we use something referred to as the dot notation. And we have been using it like ever since we wrote our first system.out.println. Okay, system.out.println. That's our dot notation right there at work. So now what we are learning is that you can have a dot like that follows the name of a reference variable. For example, myCircle from the previous slide, and you can have myCircle.radius. So myCircle dot the name of an attribute, and you can assign a value, or you can use that value in an expression and assign the result elsewhere, or you can use that value in an expression and pass it as an argument to a method. Everywhere you can use variables, you can use the attributes of an object. The only thing you have to remember is to access the attribute of a specific object, you have to write myCircle, or the name of the reference variable that refers to that object, dot the name of the attribute, and then you're good to go. And what's true with accessing the attributes of an object is true also with accessing, or I would say in that case, executing the methods of that object. So if I want to run the method getArea on a specific object that is referred to by the variable myCircle, then I write simply myCircle.getArea, and that's it. That's the dot notation. So generally, the dot notation is really intuitive. Okay, that's one of the good aspects also of object-oriented programming. It's intuitive, and we have been using it so much, since the beginning, just to use pre-made stuff that it flows naturally. But if you have any problem with that, bring it up now, because we are going to rely on that dot notation right and left until the end of the semester. Question from Tristan, my var would be 10, or would it be a reference value? So my var here would be, in this case, 10.0. Okay, but you got the idea. It would be 10. It's not a reference. So my var is declared as a variable of primitive data type double. So that's why I know already it's not going to be a reference, it's a double. And double is a primitive data type. And then what I assign to that, is a result of using the reference. This is where we put all of it together, right? I am using the reference variable myCircle. Okay. I follow the reference. That's what the dot means. I check the radius inside the object being referenced. That radius contains 10. So now I'm assigning 10 to double my var. But because my var is a double and 10 is an integer, well, then there is implicit typecasting that takes place. Okay, that just means that Java is going to convert the 10 to a 10.0 and assign it to my var. Okay. All right. So I'm glad if that makes sense, because it's really what you need to deal with during this lecture. Okay, you have to be able to follow the dot notation. You have to be able to follow every step of an expression. Understand exactly what's happening there, because that's what you're learning right now. You're learning to decrypt the notation that allows us to use object, to use method on object, to use the attribute. You're learning that the object is kind of a container that has attributes and method in it, and so on and so forth. Okay, and this is simple. Once you wrap your head around it, you're going to think, oh, okay, that I got it. That's trivial. But if you don't understand even like a little bit of this, then everything else in the rest of the class is going to be gibberish. Okay. Is there anything else we can access within an object beside attribute and method? I'm thinking about like weird situation or advanced situation there. No, there's nothing else you can access. Attributes and method. This is what the object contains. That's what you can access with the dot notation. Okay. Now, next to that, and now I have to tell you how much I lied. Next to that, no, I would put a little asterisk. Okay. When we deal with inheritance, you are going to learn that sometimes an object contains more attributes and more method than just what is listed in its class. Okay, but we're not there yet. So I'm putting just a little asterisk with everything that we learned so far. If the object is of class simple circle, you look at the definition of simple circle and all the attributes listed there and all the methods are going to be in the object. But sometime later, there'll be even more than that. We're going to learn about it, okay? All right. I just want to make sure, it's not a big deal, but I just want to make sure that when I tell you things like that, I put those little asterisks, because if anything else, that gives you a heads up about what's coming up next. So now you have a kind of like a mental warning, right? That says, okay, this part is going to get more complicated in a few lectures. Okay, that's good to know, right? That helps you get prepared. And when we finally get to it, it's not going to come as a huge surprise. All right, surprises are not always good while learning. All right, more about coding methods. So this is like just a side remark that I want to inject here to keep everything that I'm teaching you right now consistent with what I've been teaching you before. So before I refer to COP2513, I refer to the first 2 weeks, of this semester, where we were not using anything but static method. So we are not done with the keyword static. We're going to talk more about it, okay? So let's use this as an opportunity to take a break and figure out, what's going on here with the static methods. So you've noticed that, like for the last 2 lectures, I'm using more and more non-static method. What is a non-static method? It's just a method that's declared and you don't have the static keyword, in front of its name. So if I use non-static method, everything I told you so far holds true. If I use static method, there is a different set of rules that we have been already exploring before. So let's just focus on contrasting, the 2 possibilities. When and how do I call a static method, and when and how do I call a non-static method? So for static method, and the example I'm going to use is the method POW, POW, power, from the math class. When you call a static method, generally, you prefix it with the name of the class. And you can tell that math is the name of the class. It's not a reference variable because it starts with an uppercase letter. Uppercase letter, always the start of the name of the class. So math.pow means inside the class math, there is a static method called pow, and I want to call it. And we use static methods like that when the method can do its job without the need of being called on a specific object. We don't need to create an object of the class math, to just elevate 3 to the power 2.5. We just tell the power method, I want to elevate the value 3 to the exponent 2.5, and that's it. So in those cases, this is how we have used methods, in COP2512. In those cases, a class is just a repository of a bunch of methods, and the method get everything they need to work by the parameter, and they return a value, or they do something on the screen, or write in a file. They do their job, and then that's it. End of story. What we have been doing, for the last 2 lectures is we have been defining non-static method inside of classes. And now, because we have non-static method inside of class, you've never seen me anymore use the name of the class followed by dot, followed by, for example, getArea. Instead, I had to create an object of the class simple circle, and then I had to use the reference variable that was referring to that object to call getArea with a dot notation. Okay, so can I actually write simple circle dot getArea? The answer to that is not really, because this is something that is allowed only for static method. GetArea is not a static method, so the moment I decided to not put the static keyword in front of getArea, I decided that you needed to call it on an object. Why did I do this? Well, I did this because to be able to compute an area, I need access to the radius. Where is the radius stored? The radius is stored inside each object. So if you want me to compute an area for a specific circle, you are going to have to point me to the circle that you're talking about. And once you give me pretty much the reference to that circle, then I'm going to be able to look at its radius, then I'm going to be able to do its job. So non-static methods are methods that are meant to be called on specific object, and they are going to do some work that's going to involve the values in the attribute of that object. That's the general rule. okay? Or they are going to change the values of that specific object, or they are going to write to file, or enter in a database the values of that specific object, okay? So one type of method works at the class level. Static method are just working at the class level. They get everything they need from their parameters. The other type of method, non-static method, work at the object level, and they get everything they need to do their work from the parameters as well, but also by being called explicitly on a specific object with this notation, myCircle.getArea. Okay? First exposure to that. We are going to next lecture. We are going to again wrap up, the static, non-static stuff. I'm going to look at all sorts of at least 2 different examples that should cover, everything that can happen with static, non-static. But for now, let that sink in. Okay, that explanation that we went over together. Let that sink in, and next lecture we put the second layer of fresh paint on top of your understanding. But you have a few days here to ask questions. Make sure that the concept is okay for now. All right. So we are still exploring pretty much what we can do with those attributes and stuff like that. So this is going to be another remark here, another remark about the fact that we can use attributes that are of any available data type. So that means primitive data type. And generally, when you start showing people how to use attribute, you want to show them the simple attributes. So the simple attribute would be attributes which data type is, for example, int or Boolean. Okay, so the primitive Java data types, no problem. Everybody understands an attribute is kind of like a variable. All right, so we can have a variable of type int and Boolean. But I can also have a variable of type string. And remember what we learned about those. We learned that they are reference variable. So the variable itself doesn't contain the string. It contains a reference to the object of class string that's going to contain the text that the string is supposed to represent. Well, remember what I told you, everything that you learn to do with variable, you can do with attribute. So I could have a class student here, public class student, and I define 3 attributes inside this class. The age, easy, it's an int. The is science major, it's a Boolean, true or false. And the name is actually a reference variable. So inside an object, a specific object of class student, okay, for example, the object that represents student John Smith, okay, well, inside that object, I'm going to find an int value, the age, a Boolean that tells me if that person is a science major or not, and then I'm going to find a name, which is a reference to what? To another object. Remember those UML class diagram and object diagram? Well, if I wanted to represent what's happening in memory with a UML object diagram, I would have one box for the student object that represents the data on John Smith, one box for a string object that represents the string John Smith, and there would be a link, there would be a reference that goes from the attribute name inside the student object to the string object. Okay, so now we can link objects to one another. We can have a bunch of objects in memory, and it's kind of going to look like a graph a little bit, right? There are going to be references. This object is going to say, I refer that to other object, etc. Imagine that you have like a field that is like, for example, roommate in a student, and the roommate is going to refer to another student object. So all data types are acceptable, including all primitive data types, all reference data type, and this in turn includes as well the reference data type that you are building right now by creating the class student. So I could have a field here called student, that's the data type, roommate. And that's going to be a reference to another object of class student that I'm going to take care of creating whenever I need it, right? That's represent who is my actual roommate. All right. So again, in this slide, pretty much nothing new, just clarifying that everything that you can do with what we just learned. We just learned something very simple, how to define an attribute, but look at the ramification. Look at all the implication of the fact that we can now use attributes like this. This is where things are scaling up pretty fast. So keep an open mind, ask questions. If you're not sure if you can do this or that, these are good what if questions, to bring into the chat or office hours or whenever. All right. Now, let's talk a little bit about default values. All right. So when you say, I ask you, to declare your attributes like this: string name, int age, boolean is science major. And then I told you the constructor should be the one that goes in those attributes and assigns their default values when it's called. Okay, awesome. But what if the constructor forgets to assign, for example, a value to age? Or what if I don't write a constructor? Look at this class. It does not have any constructors. What happens already when we don't have any constructor? Java inserts a default constructor for us. What does the default constructor look like? It takes no parameters, and it does nothing. So if it does nothing, that means it's not going to assign a value to name, it's not going to assign a value to age, it's not going to assign a value to is science major. So what happens when you declare attributes and either on purpose or not, your constructors does not assign a default of an initial value to one or more of those attributes? Well, Java is kind enough to provide default value for the attribute inside an object. So every time you create an object, Java is going to create the object in memory, put some default value, some very dumb default value inside every attribute. And I say they are dumb because generally they are not what we want, okay? And then it's going to call your constructor and say, okay, do you want to change any of those default value? Do you know better than me? Do you know better if the age should be a default at 0 or default at 18 or something like that? And then the constructor will go ahead and change those values, okay? But even before the constructor does its job, all the attributes have received a default, factory reset value in them, okay? So what are those values? Everything numerical, int, long, float, double, that's going to be the value 0. So 0 for an int and a long, 0.0 for a float and a double, obviously, okay? But my point is that anything numerical gets a 0. A Boolean, by default, gets a value of false. Yes, it's a little arbitrary, but you just have to remember it, right? Default Boolean value is false. But what about references? So here's the problem. When you say, I have a string name attribute in the class student, okay? You didn't say that we are going to necessarily have a name, a string object to represent that name. That's a separate object. So all you said is, inside every object of class student, I have a reference variable named name that is meant to hold a reference to an object of class string. And this is why, ever since COP2513, I always read things very pedantically. The variable name, or in this case, the attribute name, is a reference attribute meant to hold a reference to string. It's meant to hold a reference to a string object, but doesn't mean that it has a reference to a string object. It doesn't mean the string object exists, okay? All you are saying is like, I have this envelope, and the back of the envelope is meant to hold an address. That doesn't mean that I know that address already. That doesn't mean that the house that's supposed to be at that address exists, or that is built yet, or anything like that, right? So that's a concept of reference variable. So yes, name is an attribute meant to have a reference. By default, when you construct an object of class student, Java doesn't have an ID where this object of class string that represents the name of that particular student, it has no idea where it could possibly be right now. So it's going to say, you know what? I don't know. I don't know where the string object is. So to say that you don't know where an object is, or that you don't know if either that object exists, you put the default value null inside the attribute name. So null is a Java keyword. We've seen it a few times. We've used it even, I think, a few times, but very informally. So null is a default value for an attribute of type reference. And it means I don't have a reference. Anything but null, it represents a memory address where if you go at that memory address, you find the object that we're talking about. So you have a proper reference to an object, okay? But as long as you don't know which object it is, you put null. You can assign null yourself to reference variable. Java is just doing it automatically here for the attribute name in this example. Okay. So we have a nice way here to have like sort of a default initialization, and then we can change things and make them better, by having actually our constructor do his job. So to sum up, null is going to be used for any reference data type, okay? 0 is going to be used for any primitive data type that is of numerical nature. False is going to be used for any Boolean. And then single character \U0000 single quote. This is one character, okay? You can tell because we are using the single quote. So in Java, remember, single quote represents one character, no matter how many letters you have in between, and double quote represent a sequence of characters. So in this case, we are using the Unicode of a character, and we use Unicode 0. So by default, a char attribute, so it's a primitive data type, again, named char, which represents one character. The char attribute in Java is going to always receive Unicode 0. And I don't remember, I think the Unicode 0 character is referred to as NUL, uppercase letter. I would have to double check. But the bottom line is that this is a placeholder. This is a null character. This is a character that doesn't, if you try to display, doesn't display anything on the screen. It's not a letter. It's not a number. It's not a punctuation sign. Okay. So these are the completely arbitrary default values that are used by Java every time you create an object with a keyword new. Okay, so if I was to, with my current class, okay, my current class doesn't have a constructor. If I was to create a new object of class student, okay, and then I was to display the name, the age, and whether it is or not a science major, I'm going to move a little bit here. So for the name, it would display null. For the age, it would display 0. And for the is science major, it would display the value false. Okay? All right. So now that we are all in agreement on what happens with default values, okay, let's try to find edge cases. Let's try to find situation where what I just told you might not hold at all or not hold entirely. Okay, that's the best way to understand something. You understand something new. Don't go and assume that this is the answer to every possible question. Try to find actively, how to break that new knowledge. Therefore, you learn the limits of it, and you are like way better off. So let's take a look at this code here. Public class test. I have a main method. Inside the main method, I declare int x string y. So I didn't initialize them, okay? And then I display system.out.println x is the value of x. System.out.println y is the value of y. Based on what we just learned, let's start with the first one. What would be displayed here for x? Think about it. Type it in the chat window when you think you have a solution. And yes, I'm trying to be sneaky, so be paranoid. So I have a 0 already in the chat. Everybody agree with that? Okay, I don't hear anybody disagree, so I'm going to assume agreement. What about the y? This will actually print out null, and River mentioned error. So 0 and null are exactly the answers that I would have expected if these were attributes. And that's what I wanted to show you, okay? I wanted to mislead you so that you hit a wall on your way, and that's way hopefully you're going to always remember, what you just went through right now. So X and Y, the trick is that if they were attribute in the class, so if I took those definition here and I put them after, public class test, open curly brace, but before the method main, then yes, this is exactly what would be assigned to them by default, 0 and null. However, X and Y, the part where I was sneaky, is I mentioned, hey, use what we just learned that was about attribute, but I declared X and Y as local variable. Okay, so what happens to local variable in Java? Sorry. In COP2513, I always told you don't leave local variable like declared but not initialized. If you don't know what to put inside an int, put 0. If you don't know what to put inside a reference data type, put null. Okay, so I ask you to write code differently in COP2512 than what I did here. And one of the reasons for this is because here I didn't initialize myself the local variables. So I leave it up to Java. But Java is not going to initialize them either. Java always initializes to a default value attributes. But when it comes to local variables that are declared inside a method, Java doesn't care. So what happened? What does that mean to not care? That means that Java creates in memory, the variable X and the variable Y. And so creating in memory just means, you take a piece of memory, you say, this is going to be X now, and this piece of memory here is going to be Y. But what was in memory before that at the address location where X and Y are located? What were the value of the zeros and one? Because memory is constantly recycled, right? I need a variable X. I change the bits in X, to represent a value. Then when I don't need X anymore, the memory is free. And then maybe I reuse a part of X and a part of the free memory before to represent a variable Y. So some of the bits that were set in X are going to be by default set in Y, they don't represent anything meaningful now anymore, but it's still what's in memory at that address. So this is what we mean by saying that Java doesn't care about initializing local variable. It will find space in memory. It will reserve that space. Now this is a space for my variable Y, but the values of the bits at that space, whatever is there is good enough. So when you look at those bits, for example, for X, that means that X could contain any number. We're completely random. It's not really pure randomness. It's based on everything that has been happening in memory, since you started your program. So it's a problem. It's an issue, right? Because X is not set to 0 or 1 or anything that I can predict. It can be set to anything based on, what happened before in the program. And then what about a string? What about a reference variable? Well, now we're going to get a reference. It's not a valid reference. The chance is that, some random garbage bits, that were already there in memory refer to actually a string object that somehow makes sense in the context of this code. These are like odds that you don't want to play with, right? This is a case study for the improbability drive. So bottom line is, we have garbage in X and Y, but the compiler is going to be nice enough to not let us use garbage because we assumed, that the variable would be initialized. It's going to actually give us an error and tell us, nope, this is garbage. You didn't initialize the variable and you're trying to use them. And that, sadly enough, the fact that the compiler stops us and with an error is good. It's very good. When you deal with a C programming language, okay, the compiler would be happy to assume that if you didn't initialize this local variable, it's not because you forgot that local variables are not initialized to a default value, but it's because you as a programmer, you as the almighty programmer, know better. And that means that you have a plan, and the compiler is not going to challenge you. It's going to let it slide, and most of the time that results in very, very nasty bugs to trace. Because suddenly some of your variables, you thought they were starting at 0, but they started at 2, and now you go inside an array, and the array doesn't display all of its elements, or you can imagine all sorts of things, right? You have the wrong value in a variable. The kind of stuff that can happen when you run that code is totally unpredictable. Okay, depending on the value, depending on what you use the variable for. All right, so just keep that in mind. Attributes receive a default value whenever you create an object. Whenever you declare just a local variable in a method, it doesn't receive a default value. So it's very important that you initialize all the local variables by hand. Okay, the way that we have learned to do since the beginning of COP2513 and the way that I've done since the beginning of this semester. As far as attribute goes, my advice to you is just initialize the attribute in the constructor. Even if you're just going to put a 0 inside an int attribute, do it. You want to put a null inside a reference variable, do it. Is it a little bit wasteful? It's unnecessary because, Java is going to do it for us, but at least it forces me and everybody who's going to read my code to remember that, there is this attribute, and that attribute has to be set to something, and I'm going to set it to null. So it's kind of like a way to make things easier to read, to make things less likely to be forgotten. Okay? So with this out of the way, we have been talking about primitive data type and transitioning to reference data type. So here's a quick reminder, okay, on reference data types. Just one slide, just things that I want you to keep in mind as we move on to the next slide. So we are going to compare side-to-side primitive data types and reference data type. So here's a variable of primitive data type int I equal 1. Here's a variable of reference data type circle, so that could be simple circle, for example. And the name of the variables are respectively I and C. So I contains the value that we assign to it. That's what primitive data types do. C contains a reference. That is a reference to an object that actually contains the data about that circle or simple circle object. Okay, the example from the textbook use the class circle here, but you can replace the class circle by simple circle so that it connects directly to everything that we have been manipulating so far, and that will work just fine. Okay, it just has to be the name of the class. All right, so that's the major difference. And then a side effect of that major difference is that if I assign I to j, and we talked a lot about that when we did the swap method, okay? When I assign the content of j to I, in the case of a primitive data type, I contain 1, let's say, j contains 2, then I make a copy of the value 2 inside of I, but then I can modify I and j completely independently, okay? This is why our swap method were not working. And in the case of reference data type, well, let's say that we have a C1 and C2 variables that refer to simple circles object. Okay, here I have C1 refer to one particular object, C2 refer to another object, and I'm using here the UML object notation. Okay, so I'm making a UML object diagram pretty much here. And if I assign C2 to C1, then here I don't copy objects. Okay, what I copy again is the value. So I'm assigning C2 here to C1. So I copy the value that is here inside the variable, reference variable C2 into C1, which means that both C1 and C2 now have the same value inside of them, which means they both reference to the same object. And what happened to this guy? This guy here, this object, still exists in memory. I didn't destroy it. All I did is I used to have a reference to that object in C1, and now I overwrote that reference by another reference so that C1 refers to a different object. So I no longer refer to this object with the variable C1, but it's still there in memory. If another reference variable was referring to it, then that would be fine. Okay, I don't want to destroy an object that 50 other reference variables are actually currently referring to, because that means that there's 50 other opportunities in the code for a code that needs to use that object. So I'm not going to destroy that for them. But personally, the variable C1 for my case, for my code, doesn't need to anymore reference that circle object. All right, that's it. So this object is called, if nobody else refer to it, it's called a dangling reference. Okay, that means that, well, it's still there lingering in memory. Maybe some other reference variable refer to it, maybe not. And then that means it can be potentially a waste, right? If nobody refers to it, why would we keep it? So that brings me to the next topic. What happens if, right, let's start with the opposite. What happens if not all reference to an object are lost? Well, nothing happens. I change one reference, it's no longer referring to that object. Every other reference is free to continue its life, normally refer to that object, use it, etc. All other part of the code can continue using that object, no problemo. But what if all references to an object are lost? What if I had only one reference to that object, like the piece of code that I had on the previous slide? I have only two variables, C1, C2. Each of them refer to its own object, and then I assign C2 to C1. Now both variables refer to the object that was referred to by C2. What happened to that other object? Well, that other object is lost. Okay, so this is an example of how we can end up losing all the reference to an object. We can assign to a reference variable, which is the only reference variable that knows about that object, a different value. And in this example, I used a different value that was also a reference, but I could assign null. What if I assign null to C1? Well, suddenly C1 contains a reference null, which means it's no longer referring to any object. But what happened to my object? It's lost. That's it. I don't have any other way to access it. I don't have any other way to use the dot notation to access one of its attributes or to access one of its method. So what happens next? What happens when we have one or more objects? What happens when we have 1,000 objects that are lost like that in memory? Well, each of them is still holding onto some piece of my memory and it won't let go. But I don't have any way to ever access the content of that memory, the attributes or method that are there. So what's going to happen? Waste of memory, and eventually I run out of memory? No, there's a component of the Java virtual machine called the garbage collector. So the Java garbage collector, and not the Java's garbage collector, is going to keep an eye on those kind of objects. It's going to check that every single object that occupies memory, okay, has at least one reference left to it. If that's the case, nothing to do. At least one variable knows where to find that object. I cannot predict if the programmer is going to use that variable or not to do something meaningful with that object. So I'm going to leave it be. The memory is used, but it's usable. It's referenceable. But what if I lost all the reference? What if my object is actually lost? Then the garbage collector, that component of the JVM, is going to kick in and it's going to say, I'm going to reclaim that memory. Because technically, there's no way the code can access it ever again. So if it cannot be accessed ever again, why would I keep the values of all those attributes, right, in that object? Why would I keep around the subject with all of its method? So the role of the garbage collector is to collect garbage, to reclaim what is called as garbage, which are the objects that have no longer any reference to them. Which means you can actually ask Java to get rid of an object for you. We never did that, right? We always create object with a new keyword, but you never saw me use a keyword like delete object or something like that, right? It's because most of the time we don't care about deleting object. We just let the garbage collector do its job, and Java is smart enough to know when it can actually safely dispose of an object. Well, not all programming languages are like that. Objective-C, that was used intensively for iOS development. I have to check if it's still actually the primary language, but Objective-C, the C programming language, the C++ programming language, all of those languages, family of language, they use explicit memory management, which means that not only you tell when you want to create a new object, but you also have to say when you want to dispose of its memory. It's a responsibility of the programmer. In Java, things are a little bit easier because of that garbage collector. But if I find myself in a situation where, I have an object and I know I'm not going to use it, then the way for me to tell the Java garbage collector that it should dispose of that object is by making sure that I remove all reference of that object. If I have only one reference variable that knows about where this object is located, then assign it to null. That's it. I assign it to null, I lose the previous reference value, I no longer know where to find that object, and therefore the garbage collector will reclaim it. Will reclaim it in the future and at a time of its choosing. That's the deal. Okay, if you want to control exactly when the memory is reclaimed, you need to program in a language like C, C++, no, C# doesn't work like that, but C and C++ definitely work like that, or Objective-C. All of those languages put you in control. They don't do anything automatically for you, but they will let you dispose of an object right away. In Java, because there is this automatic system, then you just have to rely on the automatic system, and the automatic system has an agenda of its own. It's not going to reclaim the memory right at the moment where you assign null to the last reference variable that knew about an object. Okay, it will happen, but it will happen later, and you cannot necessarily really easily predict when it's going to happen. This is called the garbage collector policy. Okay, you have to explore how the garbage collector is implemented if you're curious about that topic, and look at exactly what it's doing and when, and then you can have enough understanding to predict. Most programmers do not care. Most programmers are saying, yeah, sure, get rid of that object whenever you can get around to it. But it's because most programmers do not need the object to be disposed of, right away. Can you think of a type of programs where it would be an issue actually that I don't reclaim the memory instantly? Say something in the chat if you have an idea. A type of application, I should say. Like for example, Excel. Does it matter? A spreadsheet? Not really. Mobile device, yes, I like it. Your thinking is the right direction. Can I repeat the question? Absolutely. Is there a type of application where you think it would matter that if we write our application in Java, we cannot really tell when the memory is going to be reclaimed for an object, when the Java garbage collector is going to do its job? So River was saying mobile devices. Yep, you're headed in the right direction there. So I was talking about, a spreadsheet application on my desktop computer. I don't care. I just erased a bunch of cells, or I erased an entire spreadsheet. Okay. That means that somewhere there's an object that's no longer used, right? Is it deallocated right away? Is the garbage collector going to kick in and immediately realize that we can save a little bit of memory? No, it's not going to kick in immediately if my spreadsheet is written in Java, and that's fine with me. Okay. I'll let it kick in later, like in a few milliseconds, in a few seconds, in a few minutes, even. I don't care. Whenever it feels that it's appropriate, it's going to do its job and reclaim that memory. But now if you go toward mobile device, and I will go further than mobile device, because if I have a spreadsheet of my mobile device, it's also not super important, that I dispose of memory. But yeah, video game or subject, that's one of them. So if I go beyond like mobile device and I go to embedded systems, real-time system maybe, or I stay with desktop application, but I talk about video games, for example, which are also real-time system. Now I have an issue. My issue is I have, for example, frames to render. I need to render as many frames per second as I can for my video game. That means, manipulating all those polygons, etc. So I'm in the middle of crunching, rendering a frame, and then suddenly, out of the blue, the garbage collector kicks in and say, hey, you remember 5 minutes ago when you set that variable to null? I think it's a great time actually to go ahead and process all of the objects that are lost in memory and take out all the garbage. So I'm in the middle of pretty much rendering, one of my frames, and I am on a clock. I have only a few milliseconds, to do it so that I can maintain my frame rate. And then the garbage collector takes control and works, for example, for 10 milliseconds, trying to figure out, is there any object in memory that needs to be reclaimed? Oh yeah, there are 3 of them. Let me reclaim them now. There you go. I did my job. You have a little bit more memory now. I don't care. I don't want to reclaim the memory right now. There are times in my programs where I want to have real-time control of what's happening. So think about video game is a great example. Any form of embedded system, like the systems that you have in avionics, okay? Any physical system that you are controlling, whether it's in a factory or drone or whatever, you have to have your programs react in real time to actually external events. Okay, you cannot have your self-driving car decide to go into garbage collection, as you are approaching a cliff, for example. So all of those applications, generally, we use different languages. We use language, well, first that are real-time language. We use operating system also that are real-time operating system. Okay, so it's a very different word from application development or mobile application development or web application development. Okay, but for those programmers, definitely a garbage collector, you have to be very careful. You have to know exactly how it's going to work. be able to predict how it's going to work, and you have to be able to configure it so that it works the way that you want. And again, this is a totally different word in programming. Okay, so just keep that in mind. I wanted to bring that to your attention so that you don't go assuming that, oh yeah, it's fine to have a garbage collected language. These are the language of the future. Yep, it's not always fine. Okay. Somebody said you have to head out. Yeah, I bet I'm 2 minutes over time. I apologize for that. So we are done. We're going to stop here. This is a good time to stop. Next time we are going to revisit our swap fest. But lecture is over. I'm going to stop the recording. And as you know, we are going to transition into office hours. So if you have any question, please hang around and then ask your questions. All right. Thank you, everyone. Let me stop the recording now. I will eventually stop the recording. I promise you. There we go.